Okay, now we look at example 2. Solve the improper integral, integration from 0 to infinity, x e the power of negative x dx. This is actually from previous semester papers, semester March 2015, question 2b, 7 marks. Okay, step 1, we need to solve the indefinite integral. Okay, so how to solve the indefinite integral? Okay, we need to evaluate using integration by part. Okay, this is exponential function, so this is repeatable function, so we can use tabular integrals. Okay, when we use tabular integral, we need to use table with 3 columns. First column should be sine, and then u, and then the last column should be dv. Okay, and when we use tabular integral or integration by part, we need to identify which function as u and which function as dv. Okay, from x here, x is algebraic function, so we denote as a. Okay, e the power of negative x is exponential function, so we denote as e. Okay, from Logiter Rule, okay, L-I-A-T-E, so you can see that a comes first. Okay, here a comes first, so we can choose u equals to a. Our a now is x. Okay, so our u is x, and the other function become dv, means that e the power of negative x become dv. Okay, and after that we finish column u first. Okay, so column u we need to differentiate, so we differentiate x. Okay, it become 1, and then we differentiate 1 equals to 0. Okay, and we need to stop here. Okay, so we just use 3 rows. Okay, because the third rows we have 0. So we stop until we differentiate and the answer give 0. Okay, if we differentiate algebraic function. Okay, after we finish column u, okay, we can complete column sine. Okay, the first row in column sine should be positive sign. Then we alternate the sign. Okay, after positive, so negative, and then positive back. Okay, if we have 4th row, 5th row, and so on, negative and then positive back. Okay, and after that we complete column dv. Okay, we already have e the power of negative x in dv in first row in column dv. Okay, in column dv we need to integrate. In column u we need to differentiate. Okay, so we integrate e the power of negative x. We can use this formula. Okay, integration from e the power of ax dx equals to 1 over a e the power of ax plus c. Okay, so our a now is negative 1. So after we integrate, we have e the power of negative x over negative 1. So over negative 1 means negative. Okay, negative e x, negative e the power of negative x. And from here, we integrate again. Okay, so when we integrate, we have negative, and then we already have negative in front. So the answer is positive e the power of negative x. Now we complete all 3 columns and 3 rows of this tabular integral. Okay. Okay, after that, we can write the function that we need to integrate. Okay, So integration of x e the power of negative x dx equals to, okay, so now we multiply. First, we multiply sign first. Okay. Okay, the sign here is positive. This one positive and negative. So when we multiply positive, positive, negative, so we have negative sign. Okay. And then we multiply the function. Okay. X and e negative x. So we get x e the power of negative x. And then we multiply the sign, okay, negative, positive times positive. Negative, positive, positive. So the sign is negative. Okay. And then we multiply the function. 1 times e the power of negative x here. Okay. And after that, for the last row, we need to multiply horizontally. Okay. So from here, we need to put integration sign. Okay. So we multiply e the power of negative x by 0. So we have 0. And then we must put integration sign and dx here. Okay, 0 we get from, we multiply this. Okay. And after that, we simplify. So we have negative x e the power of negative x minus e the power of negative x plus c. Okay. How we get c here? Because when we integrate 0, okay, the answer should be c, which is constant. Because from derivative, when we differentiate any constant, it becomes 0. So means that when we integrate back 0, it becomes c, constant. Okay. Alright, now step 2, evaluate the definite integral. Okay, use upper limit b equals to infinity. So from the given question, what we do is we replace upper limit infinity to finite b. Okay, and then it is equals to x e the power of negative x minus e the power of negative x from 0 to b. Okay. How we get this integration equals to e the power of x e the power of negative x minus e the power of negative x. Okay, it's come from step 1 when we integrate this function using integration by part or using tabular integral. Okay, we evaluate indefinite integral. Okay, in step 1. Okay, so we get this. But no need to put plus c here. Because now we evaluate definite integral. So we must put from 0 to b here. Okay. Okay, after that, we need to replace upper limit b into variable x. Okay. So we substitute b upper limit into x here, and x here. So we get this. Okay. And we replace lower limit 0 into variable x here. Okay. And in between should minus sign. Okay. When we substitute lower and upper limit. Okay. And then we have b e the power of negative b minus e the power of negative b minus 0. And then e the power of 0 is 1. Okay, after that, we simplify. So we have b e the power of negative b minus e the power of negative b, and then minus minus, so plus 1. Okay. Okay, step 3, solve the improper integral. Means that we solve the given question. Okay, the given question is integration from 1 to infinity x e the power of negative x dx. Okay, we can write equals to limit b to infinity, integration from 1 to b, x e the power of x dx. Okay, this is actually under type 1. Okay, for improper integral, which is infinite upper limit. Okay, and we can use this formula. Okay, integration from a to infinite upper limit, fx dx equals to limit b to infinity, integration from finite a to finite b, fx dx. Okay, this is formula under type 1. Okay, what we do is we replace infinite upper limit by b here from this formula, and then we must put limit b to infinity. Okay, and after that it is equals to limit b to infinity, b e the power of negative b minus e the power of negative b plus 1. Okay. Okay, how we get this? Okay, from step 2, we evaluate integration from 1 to b x e the power of negative f dx. And the answer is b e the power of negative b minus e the power of negative b plus 1. Okay, we get this from step 2. Okay, when we evaluate integration from 1 to b x e negative x dx. Right? And after that, we can move down negative exponent using properties of indices. So we have limit b to infinity, b over e the power of b minus 1 over e the power of b plus 1. Okay. And from here, we can evaluate limit 1 by 1. Okay. Okay, number 1, we evaluate limit b to infinity, b over e the power of b. Okay, using this step. Okay. Okay. For number 1 here, after we use direct substitution, okay, we substitute infinity into b here, we will get infinity over infinity, which is under type 2 indeterminate form. Okay, do you remember what should we do if we have type 2 under indefinite form? Okay, what should we do? We need to use Logiter Rule. Okay, so here we need to applying Logiter Rule. Okay, means that we need to differentiate numerator and denominator. But now our variable is b, so means that we differentiate with respect to b. Okay, so we differentiate b, okay, equals to 1, and we differentiate e the power of b equals to e the power of b. Okay, and after that we can substitute limit into b here. So we have 1 over e the power of infinity. Okay, and 1 over infinity is 0. So the answer is 0. Okay. Okay. Number 2. Okay. To evaluate limit b to infinity 1 over e the power of b, we just use direct substitution. Because when we use direct substitution, okay, we have 1 over, okay, we substitute infinity into b here, so we have 1 over e the power of infinity, which is determinate form. Okay, so we can use direct substitution. Okay, so after we simplify, we have 1 over infinity, and 1 over infinity is approached to 0. Okay, so the answer is 0. Okay, okay, number 3, we evaluate limit b to infinity 1. Okay, okay, if we evaluate limit constant, so the answer should be constant because no variable b here to substitute. Okay. Okay, and then from 1 to 3 here, after we find the limit one by one, okay, we can substitute here. So we have it is equals to 0, okay, minus 0 plus 1 from here. Okay, after we evaluate limit, no more limit expression here. Okay, and then the final answer is 1. Okay, and because the final answer is finite, okay, so it is converges. Okay, got it? Coming up next, improper integral under type 2. Hope you enjoy watching this video. Thank you for watching. Stay tuned. Bye. Assalamualaikum.